Welcome back to those of you who have been here. Welcome into all of the new faces. This quarter, I'm teaching, and we're talking about science versus evolution. This is week 2 of 2, talking about matter. This is week 4 overall. Last week, for those of you who were here, we made an argument about matter. Does anybody remember what the argument was? Not all at once. Go for it.
I partly remember, we talked about matter cannot be created or destroyed or changed,
okay.
But God lives outside of the laws, mm-hmm. and also time,
right?
And also everything that we know that is matter. He's outside of it.
Yeah. So matter cannot be created or destroyed. It can only change forms. That's the first law of thermodynamics. We also looked at the second law of thermodynamics. Does everybody remember what that says?
As time increases, entropy will also increase.
Okay. As time increases, entropy will also increase. And why does that? How does that relate to matter?
Because it breaks down into forms which will eventually become less and less usable.
Cool. So as time increases, the entropy increases, and matter will consistently become less and less usable. So if you just let time run, matter will eventually fully deplete itself. So we were left with an either or. Either matter popped into existence at some point, or it's always existed. But the first law of thermodynamics says that matter can't just pop into existence. And the second law says that it can't have always existed, because if it always existed, it would have already deteriorated. We sort of looked at that paradox of given an infinitely historic timeline, matter would have already deteriorated. So under our naturalistic atheistic assumption, should matter exist? If these laws held true, should there be any matter? Does matter exist? Meaning that either the laws broke, which you can't have under naturalistic atheism, or naturalistic atheism is wrong. 6 of one, half a dozen of another. There was the 5-minute bell. I told y'all.
It was 5 minutes late. I'm sorry.
Well, we were like 2 minutes late getting out of services, so...
Technically, it's only been 4 minutes and 52 seconds.
Technically, it's only been 4 minutes and 52 seconds.
So about your 5-minute bill.
And then this is where we left off last class. Once we looked at those arguments showing that matter shouldn't exist, we looked at several atheistic solutions to that problem. We looked at quantum mechanics, we looked at the zero energy balance, we looked at the singularity, and we looked at various ways using those arguments that they have tried to explain away this issue. Okay? And where we left off was that we were going to look at the multiverse. We're borrowing from comic books for science now. I love it. Their hypothesis is that the multiverse exists and that somehow solves the matter problem. The arguments that we have looked at as it relates to the laws of thermodynamics, we've looked at assuming a closed system. And we touched on this very briefly last week. I said that we'd get to it this week. And so here we are. We're getting to it. What the first law of thermodynamics states that if it's a closed system, if nothing else happens, then whatever energy we put into the process, whatever process happens, and then whatever energy we get out of the process, the input has to equal the output. So if we had no matter at the start of the universe, I don't care what happens in the process, we should have no matter now or at the end of the universe. That assumes a closed system. What about not a closed system? What about an open system? If we put in 100 matter at the start, and then we process it, turn some of it into energy, turn some of it back into matter, but in the process we add 50 matter and we take 25 matter away, what's our output going to be? 125. We put in 100, we got out 125. So the input doesn't equal the output because it's not a closed system. So if it's not a closed system, if our universe is not a closed system, then our argument from the first law of thermodynamics loses a lot of its power. Because maybe we did start with no matter, but it's not a closed system, so we just added matter from an external source, and that's how we have matter as an output. Our argument from the second law of thermodynamics loses a lot of its power too, because maybe we started with no matter, maybe we started with some matter, but during the process, whatever matter had deteriorated, we just added more and replenished our usable supply. If the universe is not a closed system, then our arguments from the laws of thermodynamics lose a lot of its power. So their solution is that there is some sort of outside source for matter in our universe, namely a parallel universe or a multiverse of universes. Ironically, there is an outside source for matter in our universe. We would all agree with that. We just don't agree what the outside source is. Okay? They claim that the matter and energy in our universe simply came from some other universe in the multiverse system. Somehow. We don't really understand how it works. We can't even really begin to define the method, let alone to understand it. But somehow, some other universe unlocked the door between that universe and our universe and just gave us some matter and energy and then closed the door off again. Makes perfect sense. I love it. Ground rules for the multiverse. We cannot access the multiverse by definition. Thus, we cannot test anything about the multiverse. We can't run tests on it. We can't really form hypotheses about it. Nothing. We can't even ever truly know whether or not the multiverse exists based upon how it's defined. But it's obviously there. Of course, it's obviously there, and according to the atheist, the multiverse is absolutely an explanation for how matter can appear in our universe. This is a professor of mathematics and astronomy at the Queen Mary University of London. His name is Bernard Carr, and he said, simply, if you don't want God, you'd better have a multiverse. This is an open admission of what science has devolved to. It started out as a search for truth. It started out as, let's discover how things work. Let's discover the processes, the reasons why our world works the way that it does. But it's no longer that. Science has devolved now not to a search of truth, but to a way to get out of explaining God, or explaining our way out of having to believe in God. And ironically, this quote actually admits more than you might first think when you look at it, because what this is actually saying is that according to the laws of science, according to our basic understanding of how things work, God is the natural conclusion. And so you have to conjure up a multiverse in order to get out of that natural conclusion. Despite what you might hear, science absolutely points to God. This is living proof. How the multiverse, quote-unquote, works. Universes exist in the multiverse system as universe bubbles. I didn't buy bubbles or bring bubbles to class. That would have been kind of fun and a little bit more messy, so I probably should have. But universes exist in the multiverse of universe bubbles. If you were to blow a bunch of bubbles in the room, there would be circular objects floating around in the room space. Sometimes they would bump into each other. Sometimes they would just land on the ground. Universes float around in the multiverse as bubbles. And then these bubble universes can sometimes duplicate and then also collide with each other. And we'll tackle both of those individually. Anybody have ever seen a picture of like organic cell duplication? When cells split from one cell into another. That's kind of how bubble universes duplicate. The universes exist. There's some sort of inflation, expansion process. Some of the matter goes into one side, some of the matter goes into the other, and then it pinches off, and then they separate. And there's two universes from whence the one first was. Okay? The bubble universes can duplicate, and then they can also collide with each other. So just as the bubbles in our example would have floated around the room and then hit each other, universes within the multiverse can apparently collide with each other. And when this collision happens, a whole bunch of crazy stuff happens in the universes that collide. Crazy, crazy stuff. We can't even really begin to understand what crazy stuff or define what kind of stuff could happen because, again, ground rules for the multiverse, we can't test anything about it. But trust me, crazy stuff happens when these universes collide. So theoretically, in the multiverse, infinitely many universes exist. And across those infinitely many universes are all of the infinitely many possible timelines. And if we want to get strictly technical, all of the infinitely many possible timelines exist infinitely many times. There's a bunch of universes out there. If you can conceive of a possible timeline in your finite human brain, it exists. So there's a timeline out there where Michael Jordan weighed 500 pounds and dunked more cookies into milk than he did balls into hoops. That timeline exists. There's a timeline where pizza became sentient and was arguing about whether pineapple belonged on humans. okay, there was a timeline where the laws of thermodynamics didn't exist. And that would allow for matter to pop into existence. It's conceivable, which means that it's not only possible, but it has happened infinitely many times in the multiverse. So their theory then is that such a timeline exists. A timeline where the laws of thermodynamics don't apply, the laws of thermodynamics don't exist, and so there's a universe out there where matter can and does just pop in and out of existence at will. And that universe duplicated itself, creating our universe from that universe, and then either in that duplication process or as a result of the collision, the laws of thermodynamics were created. So we got matter because in one timeline the laws of thermodynamics didn't exist, and then now we have matter and the laws of thermodynamics. Such a simple theory, right? Who would expect there to be any problems with this? Okay. Problem number one is string theory. There's at least like a dozen problems with the multiverse itself, let alone the multiverse as it relates to our apologetics discussion. There's at least 7 that I could list off the top of my head right now. We're going to rearrange those a little bit, combine some, and cut several others. We're going to look at 4. But trust me, this is scratching the surface of the problems with the multiverse. Problem number 1 is string theory. It's a whole 20-minute side tangent. We can get off onto this too. We're going to try and keep it a little bit short, but we do kind of have to understand what string theory is. There are 2 major classifications of laws in modern physics. There are what we're going to call the big laws that cover the big realm. These would be the laws that we're familiar with. These would be your thermodynamics, your law of biogenesis, your law of gravity, most of the scientific laws that you would encounter and be familiar with in everyday life. And then there are laws of the tiny realm. These would be quantum mechanics. These would be what governs particles and quarks and all sorts of stuff and the interactions on the tiny, tiny, smallest realm. The problem is that in physics, these 2 groups don't work together. The laws that govern the big realm only work in the big realm, and they have no application in the tiny realm, and vice versa. Nowhere else and anywhere in all of science do we have that issue. The law of biogenesis applies just as much to the blue whale as it does to germs. Okay? The laws are across the board, they apply. In physics, we have this divide, and this is an issue. And so for decades, scientists have been searching for what they've termed the law of everything. And this would be a law that sort of bridges that gap between the big laws and the tiny laws. Whether that's redetermining and redefining the laws of physics in general, or finding some conversion factor or something to take these 2 groups and merge them together in one cohesive law system. Some scientists think that string theory is that solution. That string theory will be the law of everything that solves physics. But what is string theory? The basic building block of matter is the atom, right? So if you have a thing, it is made up of atoms. Is that still the smallest building block of matter? This is not a trick question, hopefully. This means yes, this means no. No! There we go. What is the building block of the atom then? How do you get smaller than an atom? Protons, electrons, and neutrons. And then you can get even smaller than that. You can look at quarks, you can look at other things. Even smaller increments of matter have been discovered, and their theory is that at least one more, even smaller increment is in existence, and they would be tiny, one-dimensional strings. Don't even get me started on something being one-dimensional and yet having a physical existence. That's not how dimensions work. It's okay. Tiny one-dimensional strings. Their theory is that every particle of matter is composed of these tiny strings. These tiny strings would require an additional 6 to 7 dimensions in order to even exist. So we exist physically in 3 dimensions, and then the 4th dimension would be time. There would be an additional 6 to 7 dimensions on top of that required for these strings to even exist. These strings apparently vibrate, and the vibration of these strings determines a whole host of things about whatever particle the strings make up, such as mass, electrical charge, nuclear properties, and other things. Their theory is that strings exist, and through some really complicated processes, these strings allegedly allow for the multiverse to exist. Don't ask me how. They can't tell you how. I sure as heck can't tell you how. But the strings allow for the multiverse to exist. Super important. In order for the multiverse to even be possible, let alone true, string theory has to be correct. We could prove string theory. We could have all the evidence for the string's existence, and that string theory itself be a well-fleshed-out theory, and all of it be true, and then still have no evidence for the multiverse. And that would be one issue. But if we ever want the multiverse to be true, string theory has to be true. You can't get around that. The problem is it's not. It's not at all true. It's nowhere even close. This is George Ellis. He's one of the string theory's founders, and he said both of these things. I love this quote, if we had proof that string theory is correct, its theoretical predictions could be a legitimate experimentally based argument for a multiverse. If we had proof, it's not even an actual, it's theoretical, it's not even evidence, it's predictions. It wouldn't even be proof. It could be not proof, but an argument for the multiverse. Sounds super sure of himself, right? String theory has moved from being a theory that explains everything to a theory where almost anything is possible. But string theory is not a tried and tested theory. It's not even a complete theory. Remember, if the multiverse is ever going to be true, string theory has to be true. But it's not even a complete theory. This is theoretical physicist and cosmologist Lawrence Krauss, and he said, simply, there is no evidence that it, being string theory, is correct. Astrophysicist Eric Kaizen said that there is not a shred of experimental or observational evidence for string theory. And this one's the kicker. This is George Ellis and Joseph Silk. These are both of the founders of string theory, and they said it is, as of yet, unverified. It is not, in our opinion, robust, let alone testable. What's one of the requirements for something to be scientific? String theory is not. In reality, string theory is probably not correct. There's no evidence for it, and if it's found to be wrong, the entire multiverse theory crumbles to pieces. String theory has to be correct in order for the multiverse to be possible, and it's probably not correct. But wait, there's more. There is no evidence that the multiverse itself actually exists. Even if we could prove string theory to be correct, we would still need evidence for the multiverse. But there's no evidence that the multiverse itself actually exists. And beyond that, there can never even be evidence for the multiverse. Right? And this is because of how the multiverse is defined by definition. Remember our ground rules. We can't access it, we can't test it, we can't even ever really know whether it exists. So again, what's one of our basic requirements of something being scientific?
Sorry.
Go for it.
I had this last week. Why can we not access the multiverse? Theoretically, if it was there, we would travel.
We'll get into that. That's like the next two
Cool.
slides.
I was like, I don't understand.
It's how they've defined the multiverse.
Okay, cool.
The multiverse, by definition, cannot be accessed. But what's one of our requirements for something to be scientific? You just said it. It has to be testable. Can we test anything about the multiverse? Because of how they've defined it. So not only is string theory unscientific, not only do we have no evidence for string theory, but even if we could prove string theory to be true, there's no available evidence for the multiverse. Not only is there no evidence, but we can never get evidence because of how the multiverse is defined. This guy again, this is George Ellis. We got several quotes from him. We just do not know what actually happens, for we have no information about these regions in the multiverse, and we never will. All in all, the case for the multiverse is inconclusive. The basic reason is the extreme flexibility of the proposal. It is more a concept than a well-defined theory. The key step in justifying a multiverse is extrapolation from the known to the unknown, and from the testable to the untestable. So, by their very definition, in order to justify the multiverse, you have to go into the realm of the unknown and the untestable. This guy again. Even if the multiverse exists, which is comical, even if the multiverse exists, it leaves the deep mysteries of nature unexplained. All the parallel universes lie outside our horizon and remain beyond our capacity to see, now or ever, no matter how technology evolves. In fact, they're too far away to have ever had any influence on our universe whatsoever. Which is ironic, because how were we supposedly getting matter? This theory was supposed to solve the issue of matter's existence. How did we allegedly get matter? A universe in the multiverse had influence on our universe. Through some way, shape, or form that we can't even begin to define. But if the other universes in the multiverse are too far away to have ever had influence on our universe whatsoever, then how does this solve the matter issue? It doesn't. Logic is out the window. It's okay. This is theoretical physicist David Gross, and he said that the other universes that are postulated to exist in the multiverse cannot be observed from our own universe, even in principle. This is because of how the multiverse is defined. This one's fun. This is a theoretical physicist by the name of Lee Smolin. He's a professor at both the Institute for Theoretical Physicists and the University of Waterloo. He kind of knows what he's talking about. And he says this: the multiverse theory has difficulty making any firm predictions and threatens to take us out of the realm of science. These other universes are unobservable, and because chance dictates the random distribution of properties across universes, positing the existence of a multiverse doesn't let us deduce anything about our own universe beyond what we already know. Even if the multiverse exists, and we claim that the multiverse exists, that doesn't tell us anything about our own universe beyond what we can already know. As attractive as the multiverse idea may seem, it is basically a sleight of hand, which converts an explanatory failure into an apparent explanatory success. And I'm going to read between the lines on this one. Explanatory failure being the idea of atheism and evolution, because it's founded on the fact that nature can explain itself, but clearly nature can't explain the origin of matter. So that explanatory failure has now been turned into an explanatory success, because the multiverse exists, right? We started out, though, by trying to explain why our universe is so special, and we end up being asked to believe that our universe is one of an infinite number of universes with random properties. The multiverse fails as a hypothesis. We had to invent the multiverse, and thus, with an infinite ensemble of unobservable entities, we leave the domain of science behind. In some sense, the multiverse embodies the unreal ensemble of all possible solutions to the laws of physics, imagined as elements of an invented ensemble of bubble universe. But this just trades one imaginary unreal ensemble, which, read between the lines, he's probably talking about God or some supernatural, some being here. It trades one imaginary unreal ensemble for another. Yeah.
Well, I think what's interesting is we've all had a science class before, and something to do in science classes, they'll be like, okay, come up with a hypothesis and then test it. The point of making a hypothesis, in a way, is to test something. No way to test it.
There's no way to test this, which, again, by definition, makes it unscientific. And so if you're going to base your entire worldview on science, and your entire worldview on skepticism, and your entire worldview on not believing in anything that you can't tangibly prove, why in the world would you believe in this?
Not only that, the founder of string theory itself, on that last slide, literally just disproved his own theory.
Yeah. There's a lot of logical inconsistencies.
Well, and it sounds like someone daydreamed about the multiverse that explains something. And someone, if the multiverse existed, we'd have string theory. So we have the daydream explaining a daydream that is disproved by the daydream that was explaining the daydream.
And neither daydream has any evidence whatsoever.
Actually have any evidence whatsoever.
That's the comment saying that it takes more faith to be an atheist than a Christian. And if you ever say that to an atheist, they will laugh at your face. But right there, you said it.
Yep.
It takes the exact same amount.
Yep. And that's part of why I wanted to go through this in such great detail and provide you guys all these quotes, and that's why I'm making these slides and the outlines and the video recordings of this available, is because this is a lot of information, and I'm talking a lot, and y'all are probably not even understanding, because there's a lot of text on screen, and basic PowerPoint presentation will tell you shouldn't have a lot of text on screen, A, and B, you shouldn't just read off of the screen. That's literally what I'm doing here, but I'm giving this to you guys to reference later. This is information that we all need to know.
Not only that, the whole multiverse thing originated not even from science itself, more from comic books.
Exactly. Yeah, we're borrowing from Marvel for our scientific theories and hoping that it's true.
Literally, the realm of comic books is imaginary.
And the bubble universe thing is laughable because where are the bubbles? What realm are they existing in? And if we have an infinitely increasing universe, eventually the bubbles would all collide, and it would just become one large universe. And so the whole thing is, if you actually sit down and look at it, it's hilarious because, like has been pointed out, the basic way that the scientific method works is you make an observation, you form your hypothesis. The hypothesis is not the first step. You don't just say, oh, I think this happened. So you observe something, which they have explained they have not observed and it can't. You make your hypothesis, you test it, and then in order for it to become a scientific fact or even a recognized theory, because theory doesn't mean it's not proven, it's not a law, and it has to be repeatable. You have to have multiple different independent bodies prove that, like, come to the same conclusion with the same test, and they can't test it. So it's extremely funny. And if I sat in my physics class and tried to have this level of proof, I would not be.
You'd be laughed out.
Yeah. I would be failing that class.
Well, any logical, like if you think about things logically, like you can obviously prove that Jesus Christ was a real person, first of all. But then if you're gonna say, okay, well Jesus was real, but then like the Bible is just, like these made up dreams, like that doesn't logically make sense either, because the Bible makes more sense than this, which is like literally absurd.
Which gets back to
that, the idea of the multiverse itself came from comic books as an idea. We know that it was created. It's not an actual thing in real life compared to what we've seen in real life as evidence.
Well, let's look at things out. So.
Well, and that's what he's saying here. Like, we had to invent the multiverse.
We
didn't observe it. We didn't just randomly come across it.
Scientists said, let's go look at it and see if we're right or not.
The whole Marvel thing could also just be like a testament to why it's important for us to know about this. Is because they're not just like, this isn't just some scientific theory that's existing like way off in universities. Like, they're putting this in a pop culture now. So like there's like a whole like generation that's sitting like in a teen class and down that hallway that's growing up with like,
and they just think that this is
they just think that I guess the multiverse is real because Iron Man said it is. So we got to be able to like explain that.
And as much as like all of this, how much more compassion should we have? Because as much as we can't duplicate and test creation, we understand the proof we see in science. So how much pain and suffering must they be inflicting on themselves, or must they have gone through in order to reject what we see as plain, to come up with something that takes just as much faith to believe. So how much more compassion should we have for them?
And that gets back to sort of week one, the very foundation of this class. We're not going in this level of detail, and I'm not giving you guys this information so that you can go smack people around and say, I'm right. We're not trying to win arguments. We're trying to win souls. And to do that, we need to understand this, because people just take the universe for granted. People just think the universe, or the multiverse, the universe exists. I'm not trying to argue the universe doesn't exist.
As much as we want the multiverse to be real,
it's not. But we have to understand this, and we have to be able to communicate it to people that haven't done this level of study. That's why we're going this in depth. Okay? Anything else? This is great.
You're doing a great job.
Thank you. Believe it or not, we're halfway done with our problems. These two will be shorter, though. Where did the universe come from? Or the multiverse come from, if it exists? Let's concede that it exists. We know that it doesn't. We've looked that it doesn't. Let's concede that it exists. Again, founder of string theory, very prominent advocate of the multiverse. This is George Ellis again. He says, many physicists who talk about the multiverse assume the multiverse as a context for their theories without worrying about how it comes to be. And that's what concerns cosmologists. Scientists propose the multiverse as a way of resolving deep issues about the nature of existence, but the proposal leaves the ultimate issues unresolved. All the same issues that arise in the relation to our universe arise again in relation to the multiverse. If the multiverse exists, did it come into existence through necessity, through chance, or through purpose? And that is a metaphysical question that no physical theory, so naturalistic atheism, cannot answer for either the universe or for the multiverse. It cannot be done. This is theoretical physicist Paul Davies. He said that the multiverse theory is increasingly popular, like we've talked about, but it doesn't so much explain the laws of physics or the origin of the universe as much as it dodges the whole issue. If naturalism holds true, there has to be a physical mechanism to make all the universes and to bestow bylaws on them. But this process will require its own laws or meta-laws. Where did those come from? The problem has simply been shifted up a level from the laws of the universe to the meta-laws of the multiverse. You still have to explain the multiverse. That still has laws. You would need a universe-generating mechanism. But even if we were able to access the multiverse, and even if we could run tests on it, and we found that there had to be a universe-generating mechanism, where did that come from? And it's the recursive logic, or lack thereof, that still gets back to the same question of where did all of this come from in the first place?
That's another issue as well. Let's say that we can prove it, and that's you still have to, regardless of that, you still have to figure out how it still works.
Right. Because we can prove that our universe exists. But how does it work? Where did it come from? Even if we did have evidence of the multiverse and that it did exist, we would have the same question.
There would be more questions.
Right. So again, it doesn't so much solve the issue as it dodges the issue entirely and just takes it out of our reach. And we're comfortable with that. It's just not scientific. This one's fun. Problem number 4. The multiverse actually debunks atheism in at least 2 ways. Again, let's assume that it's true. But naturalistic atheism assumes that nothing outside of our observable material universe exists. Keyword, our observable material universe. What is the multiverse by definition?
Outside of our universe.
Outside of our universe. It's clearly something. Whether it's an infinite number of universes, whether all of them have combined into one, whether there is a universe-generating mechanism, however it exists in some sort of multiverse space, it's at least something outside of our universe. So at its core, the multiverse, in an effort to prove atheism, actually debunks atheism.
Not only that, atheism also promotes the nothing theory.
Right.
Where everyone just stop existing. Just cease to exist.
Yeah, but everything is still existing.
If the multiverse theory was true, and according to naturalistic atheism, there is no God in our universe, and somewhere out there, there's a multiverse where God does exist.
Hold that thought, because that's the next slide.
Oh gosh.
Remember, in the multiverse, across the infinitely many universes, every conceivable timeline in every conceivable universe will exist infinitely many times. So like you were getting at, what's to stop a universe from existing where there's a God like the one described in the Bible?
Well, it's not this one.
It's not this one, no. But it's another universe. Could that be possible? Could a God exist in another universe? Nothing's stopping it happening, right? Like every conceivable timeline exists infinitely many times, so it has to happen. Mathematically, it would have to happen. What's one of the characteristics of God relevant to this discussion?
He is outside all perceivable dimensions. He's outside time. He's
He's outside
outside
of-
physics.
He's outside of the
everywhere
physical.
all
He's
at once.
and he's everywhere. So if an omnipresent God exists in one universe within the multiverse, by definition of who God is, because of the characteristics described in the Bible, it would be the God that we know of. If God exists in one universe, he would have to exist in all universes within the multiverse. So if the multiverse is true, in an effort to prove atheism, God exists and he's present in our universe. That's what we call in the chess world checkmate. Does that make sense? Are there any questions or comments? Anything else on the multiverse? Cool. Now we move on to the proof. I have referenced a proof several times in this class so far, and I said that we wouldn't probably have time to go through the proof and to actually show it to be true, but I said to trust me because I'm not about to lie to you guys. We got through more material last week than I thought we would, so we're going to take the extra however many minutes that we have this week and we're going to go through the proof and several of its applications. We're going to look at a proof that says that matter and time are what I'm going to call existently dependent. You can't have matter without time. You can't have time without matter. If you have one, you have to have the other. And if you don't have one, you can't have the other. Okay? And we're going to look at that by looking at how gravity works. So we're going to zoom in if I can. And we're going to assume that space... Straighten out. Imagine it's straight. It's okay. I'm not an artist. I'm an accountant. And we're going to stick with it. Space exists as a three-dimensional plane. For ease of our brain's understanding, we're going to think of it in 2D, but technically this is 3D. I'm going to draw this line up here, and then we're going to immediately disregard it for a second. I want us to imagine that we had a massive blanket, and we all stood in the edges of the room and held the blanket really tight, not to the point that it would tear, but taut so that there's no slack. What would happen if we put a bowling ball in the center? There'd be a divot. So what would happen if we were all still doing that and holding the blanket tight, put the bowling ball in the center, made the divot, and then I took a tennis ball, and I started it near my edge, and I just rolled it along the edge of the blanket? It would circle. Would it just stay on the edge? It would slowly go down into the divot. And so what this looks like, and why this is relevant, is space exists in the absence of matter as sort of a flat line. When there's matter, there's going to be a divot. Okay? And we're going to change colors because I can. When matter exists, there's a divot in space. Okay? My question, what do you think these arrows represent? You're right, you just got to say it out loud.
I did say that loud.
I couldn't hear it. Be louder.
Gravity.
And for ease of our understanding, for now, we're going to make this better later, the steepness of the arrows is the strength of gravity. So if the arrows are like really shallow, if I can draw quickly, and we had a really shallow divot because there's a really, really little bitty bit of matter, and the arrows were like really shallow, that's very light gravity. Okay? Versus the significantly heavier gravity from the bigger piece of matter. Okay? Why do the yellow lines exist?
Because they do. Because we can observe them and they are self-evident.
Okay, because they do, because they're self-evident. Can you ever have yellow lines here? Because matter doesn't exist. If you have a little bit of matter, you have very shallow yellow lines. If you have a lot of matter, you have very steep yellow lines. If you have no matter, you have no yellow lines. Okay? So I'm going to make the argument, go with me here, that matter is equal to, and I'll put equals in quotes, to gravity. Not to say that matter and gravity are the same, because they're not, but that if you have one, you have to have the other. If you don't have one, you can never have the other. Right. They're not the same thing, but they're existently equivalent. Okay? Put a pin in that. We're going to come over here. And I'm just going to say it, and then we'll see how in-depth we want to get. We're going to have another equivalency, in quotes, and that is going to be that gravity is equal to time. And this gets wildly complicated really quick because it's all founded in Einstein's theory of relativity. He didn't get it. We have no hope of getting it. We can apply it because we know that it's true. If you were at lunch last week with the 8 of us that went out to lunch, a couple of us nerded out on some astromechanics and read several scholarly articles, and this is true. Okay, and this is applications. We've done it experimentally. We've done it mathematically and theoretically. We can show this to be true. There's no way we're going to learn about it in here to any level of understanding. Okay? If you want articles, I can send you articles. If you want to spend 20 minutes talking about it, we can spend 20 minutes talking about it. But this is true. Okay? But hang on. But this is math. Right? So I should be able to just take this and drag it up to here. Forget the fact that the G's don't align. Because we can actually, if we just grab this, we can cross all this junk out, and we can say that matter is quote unquote equal to time. And there's your proof. If you have matter, you have time, vice versa. If you have zero matter, you have zero time. If you have one, you have the other. If you have neither, or if you don't have either one, you have neither. Now, why is this relevant? Like, at all? Well, we've referenced it several times this class, and we're going to look at several different applications and go back and apply it, and then we're going to look ahead and apply it in a couple places too. When we talked about the law of cause and effect, we said that if the universe, by its very existence, can be described as the sum of material existence, then by definition the universe is bound by time. And I said that there was this proof that showed it to be true. This is why it's true. If the universe exists, if matter exists, it has to be bound by time. As a part of that, we looked at what would the cause of the universe be. Looking at the law of cause and effect, if material existence exists and it is inherently bound by time, then the immaterial cause for the material effect has to itself not be bound by time. Because if you're not material, you're not bound by time. There's a whole rabbit hole we could go down about what this means about our existence in heaven, and does time actually exist in eternity, or is it just a way of describing it? I'm not going to touch that. A little faster. We're not going to touch that at all, especially now for the sake of time. But if the universe, as the sum of all material existence, exists, it has to be bound by time, and the cause of the universe can't be. Okay? There's another application, and by another I mean like 3, that comes from a couple of more drawings. So again, bear with me, I am not an artist. We arrived last week at an either or, and we said that matter either came into existence at some point in the past, or it had always existed. Right? And I know I've drawn 4 graphs up here, because we're about to make this slightly more complicated, but either it popped into existence at some point, or it had always existed. I want to add a second variable now, and say that time also could have popped into existence at some point, or time has always existed. Imagine these are straight lines. Bear with me. Can matter exist outside of time? So can this one be true? And why would that be relevant? Maybe, as an atheist, here's one of my solutions to the problem of matter popping into existence. Maybe it's just so rare that we could never see it happening. 14 billion years of evolution taking place, we'd never see it happen because it's so obtusely rare. Of course we'd never see it happen. But maybe, pause, I'm describing this one. Maybe matter existed, time existed outside of matter. And maybe it's matter's popping into existence is so rare that of course you would never see it happen. But let's say we had infinite time this way. To try it over and over and over, and to fail over and over and over until we finally had success. David, if I gave you a D20 and I said, hey, roll me a 17, could you do that first try?
Not necessarily.
Not necessarily. It might happen.
You have a 1 out of 20 chance.
You have a 1 out of 20 chance. And maybe if you rolled it 20 times, you'd still never get a 17. If I gave you an hour, could you roll me 17?
100%. Guaranteed.
So more time, meaning more possibilities for trial and error, will lead to a higher probability. So maybe matter popping into existence is just an extremely rare event, absurdly unlikely, but we have infinite time to try. Is this graph possible? This graph is not possible. So we're going to get a big old red note and we're going to say, nope, that's not how that works. Now back to this graph. What was our problem with the second law of thermodynamics? Entropy. Matter deteriorating. But matter only deteriorates as time passes. So maybe matter has always existed, and at some point in time, time popped into Time popped into existence. And so we can get around that entropy problem. Matter has just always existed and never deteriorated, and then all of a sudden, time pops into existence, and 14.2 billion years of evolution pass, and here we are. Sounds great, right? Is this timeline possible? Big old red circle, X through that. And so we're left with our either or that we started with. Either matter and now time popped into existence at the same time, or matter and time have always existed. Last week we looked at it. If matter has always existed in an infinitely historical timeline, then by the time we get to now, matter would have already deteriorated. Matter wouldn't exist. So we now know that this option doesn't work, and we're left with what 99.9% of scientists, I'm not a scientist, but I would agree with this timeline, conclude, and that is at some point in the past, everything popped into existence. But how do you do that? How does matter just pop into existence? We're still left with our same argument, but we proved it. This is going to be fun. We're gonna start this. Hopefully we get through it. This is not necessarily related to matter or time, but it is related to this gravity discussion, so we're going to talk about it here. Technically, theoretically, you want to stay 2 minutes late?
Yes.
Cool. Technically, theoretically, there is a point, and we're going to use purple, because I want to use purple. Give me purple. There is a point where time doesn't pass. Okay? And like I said, it's not technically the steepness of the arrows, it's technically the depth that determines the strength of gravity. There is a line in this depth where time does not pass. Okay? Starlight. How did we get 14 billion years worth of light from stars that are 14 billion light years away? How did we get light to Earth? This will solve that. Go back to our blanket example. If we had, say, a basketball in the center, and there's a small divot, and then we took 500 baseballs and just dropped it on the blanket all at once, and we didn't drop the blanket, what would happen to the blanket? It'd be like a little trampoline. It would boing, right? It would divot, probably more so, but initially, it would sort of just all shove down, and then would come back up to where it was supposed to be. So in theory, day 0, Genesis 1:1, God created the heavens and the earth. The earth was here without form and void, right next to the line where time doesn't pass, because the gravity is so steep. Then on day 4, when all this matter was created, when he made the sun and the moon and the stars also, hundreds of baseballs were dropped on the blanket, and all of everything moved down like that. And so what you have here is you have all of these other stars that are now emitting light, and light's traveling towards Earth, but it's still day 4 here, because we're beyond the line where time passes. And then as we drop stuff and then it springs back up, slowly but surely, this line would move down and down and down. But as it's moving down, you would have light coming from these distant stars towards Earth. And by the time time passes, and by the time, because we're way farther down than we should be, and by the time we get back up to where we should be and flatten this plane out, all of the light from billions of light years away has reached Earth. That's kind of cool. It's not a perfect solution. We'll get to better solutions when we actually look at the starlight issue. That'll be in like 2 months. Because there's issues with this solution, but it is at least a solution. Okay? Does that make sense? I know we're like 2 minutes over. Any questions, comments, anything? Any questions, comments, anything in general? Cool. Well, they want to take this down because they got a backpack drive tonight. So, with that, I will be around if you want to ask questions later.